Okay, so we just went through and finished the lab number 8 for the extreme value theorem discovery. And personally, I feel like compared to some of the other things we have worked on with labs, this was a rather easy concept for all of us to understand. What do you guys feel?
I agree completely with you. I think there was a couple parts that were a little confusing, but I think that overall it was a lot easier than most of the other concepts.
Yeah,
Yeah, I would have to agree too because like normally whenever we're doing a lab, like I'll have some questions and uh Joshua will like explain to me like any questions that I have, but I really didn't have any. I was able to grasp it pretty well.
Yeah, and it recalls to mind a lot of the foundation things that we've learned, and it's just kind of building upon those.
yeah, one thing I'm actually starting to notice with a few of these labs is there's a lot of theorems that we've like looked at. So obviously this one, the extreme value theorem. Then we had earlier the intermediate value theorem. The like concepts, like when we think about it, it's like just common sense, and it's like when we see something like this in a lab, and then we think about it, we're like, oh yeah, that does make sense actually. That is how it's supposed to work, logically speaking. You guys felt that same way?
Yeah.
I see what you're saying.
Yeah. Now, with that being said, was there anything about this that you felt hard? I'll go first. There were some of the graphs that it asked me to draw. It asked me to like put it within a domain, and sometimes the domain will have a bracket, which means that there is a point there, and that I can't just leave an open circle there. But then it'll ask me, hey, you can't have a local or an absolute maximum and an absolute minimum. There can't be anything like that, and trying to create something like that ended up being somewhat difficult. I eventually figured it out. We all eventually figured it out, but like there was a little bit of like thinking that went into play with that stuff. How do you guys feel?
Yeah.
Yeah. Th-
You can go.
Sorry, go ahead.
Okay. For me, like personally, I think like part one C, where it's the discontinuous function with an absolute maximum of something, and then no minimum, or vice versa. I think that one's like the only thing that's like super confusing for me. Not super confusing, but the most confusing. But I think the more I do it, it's the more comfortable I get.
All right. Brittany, what were you about to say?
I was gonna say that it was very consuming as well coming up with those graphs, knowing that we have to think about making the function with the oh gosh, it's slipping from me. Forgot the word. You know what? Sorry, just ignore me.
That's fine. I think you'll remember it later. It's fine. Jedi,
Yeah.
you have anything to say?
No, I'm total agreement with with what everyone else is saying.
Yeah, I think we pretty much hit it right in the center. Um, what was the other thing? Oh yeah, so in the last few questions, I'm pretty sure you guys do remember the part where it was talking about so at these maximums or minimums, what would it look like on a derivative? And we know that at those values, since the slope is zero at that specific value, in the derivative it would be y would be equal to zero at that x value. So, the one thing that I feel like we're maybe not gonna do right now, but I feel like sometime in what I think the very near future, I don't think it's gonna take a while for this to come up, is I think there's gonna be certain times where we might be given like the derivative and then be like, all right, so look at this. You see where it hits zero? Um, Draw a graph where to resemble this derivative. So for example, um, if there's like a zero at one point and then it went from like a negative slope to a positive slope, then on the original function we'd have to draw it going down and then going up with an absolute minimum, or in that case it would be, yeah, an absolute minimum at that specific point. And then vice versa, you could do the other one where it's if it goes on the derivative from positive to negative, then you'll have a maximum at that point 0, and then vice versa. If everyone understood what I was saying, or was that too many words?
Yes,
I
I
understood
understood.
it.
Yeah, but like that's one thing I really expect to see in the future. What do you guys think?
Yeah, I can see it.
And then the other thing I wonder is like how can like this be applied to the real world? I don't know if you guys have thought of any ideas on like how something like this, like these extreme values, could be applied to the real world.
No clue.
I was thinking of one, and it's like there's always those word problems where it's like, oh, a guy was standing on the roof of a tall building and threw a ball, and then obviously that would be the closed domain. And then
Oh, well, yeah.
yeah, that's one thing I was thinking of. Or like a projectile, like a cannon or a missile, something like that. Since that would have a closed domain, and it would be continuous as well.
The
That does make
cons-
sense.
yeah, the the concept, not a literal comparison, but like at work, if you're given a scope for a project, they're going to want something to be continual, except for they're going to come up with one or two like edge cases or scenarios that are going to be kind of like the empty hole, the empty dot in the line. And so that is a stretch, but that is a real life application or consideration of that.
I could actually see that. It's just I don't, the maybe like the stretch part is like I don't know how you'd like make that into a line on a graph or something like that, but who knows? Maybe someone could find a way. Maybe there's some like maybe actually what you're saying perfectly lines up with this and isn't a stretch at all, but who knows? Anyway, I think that concludes our work. It was good job that we did, and I'll talk to you guys next time.
Yep.
Right?
All right,
Sounds
see
See you
ya.
later.